Welcome back. So far we've looked at part 1 of the fire spread activity, which introduced students to the idea of modeling the fire spread rate as a linear function of wind speed. In part 2 of this activity, students used technology to develop their understanding of the meaning of least squares and the criteria used to define the best fit line. This part of the activity will probably take about 20 to 25 minutes. The app that we will use in this activity is one of the free apps that are part of the Rossman Chance applet collection. You could also use other available apps that have the same functionality. It is also possible to do this part of the activity entirely as a demo if students don't have easy access to the internet to run the app, but if they do have access, it's best if students can play with the app themselves. The detailed instructions for how students should interact with this app are included in the activity handout, but I'll take a brief detour here and switch out of the slides to demonstrate the app so that you can see what the activity is asking students to do. If you're using this activity either in an in-person class or teaching online, it's probably a good idea to demonstrate cutting and pasting the given data into the app before sending students off to do it on their own. Students should copy the data from the table in the activity so that they don't have to type it into the app, but if they have difficulty cutting and pasting the data, typing it in is an option, but they'll have to remember to start with the row that includes the variable names. After opening the app, students will see the following window. They would then delete the data in the Enter Data box and paste in the fire spread data. Next, they would click on Use Data. Notice that the scatter plot that was there before has been replaced with a scatter plot for the fire data. The next thing students are asked to do is to check the Show Movable Line box. This adds a line to the scatter plot that can be moved around to try and fit the pattern in the plot. The slope can be adjusted by dragging on the end points of the line, and the intercept can be adjusted by moving the square in the center of the line. Question 3 of Part 2 asks students to move the line around until they think they have a line that does a good job of describing the relationship between wind speed and fire spread rate. Once students think they have a good line, Question 4 has students check the Show Residuals box. They are then asked to think about what this did and whether most of the distances of the points to the line are small. This leads into the definition of a residual. Questions 5 through 7 introduce the sum of squared residuals. Students click on the Show Squared Residuals box and consider how the area of the squares that are shown represent the values of the squared residuals. They can now see the value of the sum of squared residuals, labeled SSE for sum of squared error, for their line. The final questions in this part of the activity introduce the definition of least squares regression line. Students check the Show Regression Line box and see the regression line in the plot and the equation of the least squares line. By checking the Show Squared Residuals box, they now see the value of SSE for the regression line. Now let's go back and take a look at what we would hope students would take away from this part of the activity. Recall that when students were working with the movable line in the app and they had a line that they were happy with, they checked the Show Residuals box. This added lines that represent the residuals, the vertical distances of points in the scatter plot to the line. When students are looking at the scatter plot with the residuals shown, you can ask them what happened in the app. After they have had a chance to think about the residuals as being the vertical distances, Question 4 asks them to consider whether most of the distances for their line are small. At this point, it makes sense to give the definition of residual and to have students think about what it means if a residual is small. Ask students why small residuals are desirable. They should be able to relate this back to the earlier discussion of what makes for a good line. Question 5 had students check the Show Squared Residuals box. Recall that this added squares to the scatter plot to represent the size of the squared residuals. Some students may not immediately see the connection between the squares in the plot and the size of a squared residual. Take some time at this point to make sure that they make the connection between the area of a square and the value of a squared residual. Before proceeding to question 6, you might ask students what the total area of all the squares would represent and whether they would prefer a line that makes this total large or small. After students have determined the value of SSE for their line, you can have students share their SSE values. If you are teaching online, you can ask students to type their values into the chat. You might ask students if they think that their line is the best possible line, or if they think that there might be other lines that had a smaller value for SSE. At this point in the activity, students are ready for an introduction to the idea of best fit line, and the terminology regression line and the line of best fit are introduced. Deciding which of two lines is a better line for describing the relationship between fire spread rate and wind speed is not very hard. Just compare the sums of squared error. But finding a line that you know has the smallest possible SSE is trickier. Fortunately, calculus provides the tools needed to find formulas for the slope and intercept of the regression line, but there's a lot of arithmetic involved in calculating the values of the slope and intercept. This is where technology is a big plus. The formulas that have been programmed into apps like the one being used in this activity, and all statistics packages and graphing calculators will calculate the equation of the regression line for a given data set. The final questions in this part of the fire spread activity develop an understanding of the meaning of least squares when it's used in the phrase least squares regression line. Once students have used the app to find the equation of the regression line, if time allows, you might ask them to calculate the difference between the SSE for their line from earlier in this part of the activity and the SSE for the regression line. Ask students to share the differences either in class or in the chat if you're teaching online. You could bestow the title of Best Regression Line Guesser to the student who has the smallest difference, but then point out that now that everyone knows how to find the best line, it may not be all that valuable of a skill. And of course, you can always modify this activity to use your technology of choice. The Word version of the activity will be included at the end of this module, so you can just substitute instructions for your technology for the instructions given for the Rossman Chance app if you prefer to use something different. This wraps up our discussion of Part 2 of the Fire Spread activity. Next, we have a few questions for you to think about.